So here I'm going to call the number of people other than Claire and Max to be n. And questions, what's the probability that the two people selected will include Claire but not Max? So to find that probability, we have a total of n plus 2 people, including Claire and Max. So number of ways I can select 2 people from this group of n plus 2 is that, which would be n plus 2, n plus 1 over 2. It really just comes from that. I'm not going to go over the algebra here. So then the question is, the probability means it needs to include Claire but not Max. So we need to figure out a number of ways I can select 2 people where you have Claire. So one of them has to be Claire, and then the other person has to come from this set of n. So the number of ways I can do that is just n. So the probability I'm looking for is n over n plus 2, n plus 1 over 2. This is what I'm looking for. So I'll start with statement 1. The probability that the 2 people selected will be Claire and Max is a 1/15. So again, the number of ways I can select 2 people is that, n plus 2, n plus 1 over 2. And the number of ways out of that where both are Claire and Max is just 1. So our probability of 1/15 has to be equal to 1 over the total number of ways I can select 2 people. And this is 2 over n plus 2, n plus 1. And if you cross multiply, you get this equation. And you'll see that this will give you a unique value for n. And this is also comes up in distance rate questions, but let me just do the algebra to kind of clarify why that is. So n squared plus 3n minus 28. You'll see that's the product of the 2 roots, and it's negative. That means one is positive, the other is negative, and that means you will have a unique positive value. You can certainly kind of guess that value. You'll see if it's n is 4, it's 6 times 5, which is 30. So it's easier to kind of do it that way as opposed to solving it. I mean, you can certainly do that here. This would be n squared n plus 7 n minus 4, and you'll see that's going to give you 4 unique value. And then that was the original question. Once we have a unique value for n, we can answer the original question. This will be a unique value. So 1 alone is sufficient. Statement 2 says the probability that the 2 people selected will include neither Claire nor Max is 2/5. So number of ways I can select 2 people from people other than Claire and Max is nc2, and that divided by n plus 2c2. That's really the translation of statement 2. And again, you'll see you'll be able to get a unique value for n, and let me do the algebra for that. That would be n times n minus 1 over 2. This one, n plus 2c2, would be n plus 2, n plus 1 over 2. That drops out. We end up with this equation, and I'm going to cross multiply. So 5 will multiply that term, and then 2 will multiply with that. And you'll see, again, you'll get a quadratic, and you'll get a unique value. Now we can do the work, 5n squared. And then this piece is n squared plus 3n plus 2. And then we can kind of clean up terms. 3n squared minus 11n. And then minus 4 equal to 0. So yeah, I mean, it is a hard quadratic here. But the key thing is, because that is minus 4, one solution will be positive, the other would be negative. So you don't have to worry about that there are 2 distinct values, because only one is positive. If you need to factor that 3n and minus 4, and there you go. So you'll see this factors to 3n plus 1 and minus 4 is 0. So n again is 4. It has to be a positive value. But we could have stopped right here. I mean, I think it's good to have seen these questions before, but I've kind of seen them before, so I know that you will get a unique value. But when you're doing it for the first time, there is a little bit of that uncertainty. So each statement alone is sufficient. The answer is D.